Welcome to The Explainer. Today, we're diving deep behind the screen to figure out what really makes a picture pop. Let's get into it.
Yeah, that's the big question, right? And today, we're going to unpack that wow factor by looking at the two major players in the display world.
All right, so this brings us to the main event, the battle of the screens. Let's meet the two contenders fighting for your eyeballs, LCD and OLED. Okay, so the absolute core difference between these two, it all comes down to one thing, how they make light. Think of an LCD like a window with a really bright light behind it and a bunch of complicated shutters. But an OLED? Well, that's more like a mosaic made of millions of tiny individual light bulbs. And trust me, that one single distinction, it changes everything.
So, how does this all work in the real world? Let's take a look at the core difference in how they're built, starting with the technology that's been around forever, the good old LCD. So an LCD is basically this really complex sandwich of layers. You've got this super powerful backlight at the bottom, just blasting light upwards. That light then has to travel through a whole stack of things, reflectors, diffusers, polarizers, before it even gets to the liquid crystal shutters that actually shape the image you see. It's a lot. Now compare that to an OLED. It's just so much simpler. It's a completely different approach. There's no backlight, no extra filtering layers, none of that. Why? Because the thing that makes the light is built right into the screen itself. We're talking pixel by pixel. And this right here, this brings us to the key concept, the magic word, self-emissive. It means exactly what it sounds like. Every single pixel on that screen is its own little light source, able to turn on and off all by itself. And this isn't just some nerdy engineering detail. This simplicity has huge real-world benefits. You get rid of that bulky backlight sandwich, and boom, your screens can be way thinner, way lighter. And hey, this is also how we get those crazy futuristic things like foldable phones and rollable TVs. It's all thanks to ditching the backlight. Okay, so here's where things get really interesting. Let's talk about how this whole self-emissive thing completely changes the game for one of the most critical parts of picture quality, contrast. Okay, think about it. With an LCD, that backlight is always on. So to make a pixel black, you're basically trying to close a tiny shutter to block that light. But it's like trying to block sunlight with cheap blinds. Some light always leaks through. That's why on an LCD, black is never truly black. It's always more of a dark, cloudy gray. But with an OLED, making a pixel black is the easiest thing in the world. You just turn it off. That's it. You cut the power to that tiny pixel and it goes completely dark. No light, no power, nothing. Just perfect, absolute black. And this is what lets OLEDs claim that amazing infinite contrast ratio. I mean, think about it. If your black level is literally 0, then the ratio between the brightest white and the darkest black is, mathematically speaking, infinite. And that perfect black is the foundation. It's the canvas that makes every other color on the screen just pop with this incredible vibrancy. All right, so we've got perfect blacks. But it doesn't stop there. The way OLEDs handle color and brightness, well, it actually plays a pretty fascinating trick on our brains. So, to really get this, we have to talk about something called color gamuts. It's a fancy term, but it just means the total range of colors a screen can show you. And over the years, we've gone from the old standard for HD TV to these much, much wider, more cinematic standards that can show colors that are way closer to what we see in the real world. Here's the thing, though. There's a big difference between the amount of light a screen is actually putting out, that's called its luminance, you can measure it with a tool, and how bright we think it is. And yeah, that's where our brains get involved. So here's the kicker. The research is pretty clear on this. Because OLEDs have such rich, saturated colors right next to those perfect blacks, our eyes get tricked. We actually perceive an OLED screen as being way brighter than an LCD, even if they have the exact same measured luminance. It's this wild psychological effect. Okay, but let's be real. We're not watching our TVs in some perfectly dark science lab, right? We're watching them in our living rooms with lamps on and sunlight coming through the window. And the real world, well, it brings its own set of challenges. So just think about a typical living room. The ambient light in there is usually around 200 lux. And that's just a measurement of how much light from all your lamps and windows is bouncing around the room. It's the light that's not coming from your screen. So what happens to all that light bouncing around? Well, a lot of it ends up hitting your screen and reflecting right back into your eyes. You know it as glare. And that reflection, it's a killer for picture quality. It's like throwing a thin gray blanket over the entire image. That perfect absolute black we were so excited about, gone. It gets washed out. And all those vibrant, punchy colors, they suddenly look dull and pale.
So you see, this shift, this move from just filtering a big backlight to actually creating light, pixel by tiny pixel, it's a fundamental change in what a screen even is. And it leaves us with a pretty cool question to think about. If our displays are no longer rigid windows, but these flexible, vibrant mosaics of light, what are we going to build with them next?